right, so let's try an example showing an extraneous solution. And I got a new marker. So hopefully you can see better. Okay, so I have solve x plus 1 equals the square root of 7x plus 15. Okay, so I need to square both sides of this equation. And this is where things are going to get a little trickier. Okay, right here we have the radical by itself on this side, and I know to square it to get rid of the square root symbol, but that means I have to square this side too. All right, and x plus 1 times x plus 1 is x squared. Okay, if I'm foiling, I've got x squared plus x plus 1. So x squared plus 2x plus 1. Okay, so x squared plus 2x plus 1 equals 7x plus 15. All right, now I'm to a point where I just use stuff that I've learned before. So I've got x squared, subtract 7x from both sides, I get minus 5x. Subtract 15 from both sides, I have minus 14 equals 0. Now I can factor to solve for x. And what multiplies to give me negative 14 that adds to give me negative 5 is x minus 7 times x plus 2. So my answers then are 7 and negative 2. All right, well let's go back up to our original equation and let's plug these in. Let's try 7 first. 7 plus 1 equals the square root of 7 times 7 plus 15. Okay, that's what we're hoping. Okay, so I have, does 8 equal the square root of 49 plus 15? Or does 8 equal the square root of 64? And it does. So 7 is an answer. But let's look at negative 2. If I put in negative 2, I have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. And what I get, negative 2 plus 1 is negative 1. And that right there really should be your answer. Because you can't take the square root of something and get something negative. Okay, but you could keep going, I guess. And you could say this is the square root of 14 plus 15. Sorry, negative 14 plus 15. So negative 1 equals the square root of 1. Negative 1 does not equal 1. So negative 2 is your extraneous solution. Okay? All right, so let's try another one in different situations. So this time we have one with two radicals. So we can't get a radical by itself on one side, right? Because if I subtract this one and put it over here, then I have the same problem that I have here. So I still need to square both sides. This is where it gets a little ugly. Okay, so if I'm squaring the square root of x plus 2 plus 1, that means I'm multiplying it by itself, right? Okay, so if I FOIL this, the square root of x plus 2 times the square root of x plus 2, actually let me write this out. X plus 2 times the square root of x plus 2, I'm FOILing, plus, okay, here's my outside, the square root of x plus 2, plus the inside, plus the square root of x plus 2, plus my outside, which is 1. Okay, well these two, they just cancel each other, not cancel each other, but it becomes x plus 2 square root of it squared. So this is just x plus 2. This is 2 times the square root of x plus 2 plus 1. Okay, and then when I combine like terms, I'm going to have x plus 2 times the square root of x plus 2 plus 3 equals the square root of, no, sorry, not the square root. We've got 3 minus x. Okay, still doesn't look much better than where we just started, right? But this time, I can get the radical by itself. So I'm going to subtract x from both sides, and I'm going to subtract 3 from both sides. So I get 2 times the square root of x plus 2 equals, that cancels, negative 2x. Okay, now I'm going to divide by 2, and I get the square root of x plus 2 equals negative x. Now, you could be looking at this going, well, that's negative, so it's not going to have a real solution. The thing is, x itself could be negative. So that is what it could be. So let's square both sides. So we have x plus 2 equals x squared. Okay, and now I'm going to come over here. X squared, I'm going to bring everything over to one side. X squared minus x minus 2 equals 0. So now we have x minus 2 times x plus 1 equals 0. So x could be 2, or it could be negative 1. So let's go back to our original equation and see what we have. So if I put in let's see, let me erase this right here. Let me put in a 2. This is the square root of 2 plus 2 plus 1 equals the square root of 3 minus 2. Well, this is the square root of 4 plus 1 equals the square root of 1, which is 1. Okay? And now I have the square root of 4 equals 0. So 2 is not my answer. So let's try negative 1. So 2 is extraneous in this solution. So I've got negative 1 plus 2 plus 1 equals the square root of 3 minus a negative 1. So this is the square root of 1 plus 1 equals the square root of 4. So this is 1 plus 1 equals 2. Boy, when's the last time you heard that in the math class? 1 plus 1 is 2. But that's what we've got here. All right, we'll do some more in the next video.